Hi guys, it is Miss Sandler, and I am here to go over adding and subtracting fractions with you. So before we get started, let's do a quick review about something called LCM. So LCM stands for, hopefully you remember, least common multiple. Keep in mind, anything that I am writing down, you are expected to be writing down in your notes as well. So we find the LCM, or the least common multiple, by listing the multiples of a number, and then we identify the smallest, or least, between two or more numbers. So let's give it a try with the next example, listing the multiples of 3 and listing the multiples of 4. So all I'm going to do is think about my math facts. 3 times 1 is 3, 6, 9, 12, 15, 18, 21. Now, I typically would want you to try and list out, 4 or 5 multiples, but sometimes you might have to list out a bunch before you're able to find the LCM. 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, and 4 times 7. So then we identify the smallest between the two. Well, the smallest multiple that they both, 3 and 4, have in common is 12. So the LCM of 3 and 4 is 12. So why is that important for us when we're thinking about adding and subtracting fractions? Let's move on. So we need to use the LCM when we add and subtract fractions because we must have common denominators, and the LCM will help us to get common denominators. So the first thing that we're going to want to do is list the multiples of our denominators. Then we will circle the LCM, or the least common multiple. We will then rewrite equivalent fractions using the LCM. I want you to circle or highlight equivalent fractions. We cannot simply plug in or substitute in our LCM and keep our numerator the same. We need to make sure that we multiply by the top and bottom. We'll do that in a bit. And then we are going to add the numerators, I should say, or subtract the numerators and keep the denominator the same. Okay, so now you have your algorithm, or your steps, that you can go back to as a resource. And then obviously our last step, we know always we simplify anytime that we can. So let's give it a try. Ignore the numbers. Okay, 1/2 plus 5/9. As this stands right now, I cannot add these because their denominators are not the same. So, as my first step told me, I need to list the multiples. So, the multiples of 2. 2, 4, 6, 8, 10, 12. Here's an example of only listing the first 4 or 5. Will not do the trick because I know I need to at least get up to 18 because that is my LCM. So I've circled my LCM. I now need to write equivalent fractions using that least common multiple. So what I'm going to do, I'm a big fan of my loopies. I now create 2 new fractions with the denominator. Now, you cannot tell me that 1/2 is the same thing as 1/18. Those are extremely different amounts. So, how did I get from 2 to 18? I multiplied by 9. And whatever I do to the bottom, I must do to the top as well. So 1 times 9 is 9. I have now written the equivalent fraction of 1/2. Let's do the same thing over here. 9 times what gets me 18? Times 2. So whatever I do on the bottom, I do on the top. 5 times 2 is 10. I am now ready to add my fractions. 9/18 plus 10/18 gives me a total of 19/18, and I can leave it like that, or I can change this to a mixed number since it is an improper fraction right now, which would also be the same thing as 1 and 1/18, because I know 18 goes into 19 one whole time, and then there's 1 remaining out of those 18. Those are the same things. You can leave it as long as it's in simplest form, which 19/18 is. All right, let's make sure we know we're on the next one. All right, next up we have a subtraction problem. Please make sure that you're noticing your operation sign. So first thing I'm going to do here is find my least common multiple so I can get common denominators. If you were thinking 24, 6, and 4, maybe think again. Aha. 12 it is, so go ahead and rewrite your new equivalent fraction. 6 times 2 gets me 12. 4 times 2 is 8. 4 times 3 is 12. 1 times 3 is 3, and I can go ahead and subtract my numerators. 8 minus 3 is 5. Keep the denominator the same, and this is already in simplest form. I would like you to please try the next one on your own and bring that with you tomorrow. Moving on, I want to go through the first of these two with you, since you will notice that we are now dealing with fractions that have negative signs. So we need to keep in mind our integer rules, how we add and subtract integers. So same rules apply as above. I need to get common denominators. I'm going to list out my multiples here. Oh, and 18 I see is my least. Let's make some equivalent fractions down here. So I've got negative, well, 9 times 2 is 18. 1 times 2 is 2. Minus, 6 times 3 is 18. 2 times 3 is 6. Now keep in mind that when we subtract, it's kind of the same thing as adding a negative, okay? When I'm adding two negatives, I'm just adding them together. Negative 2 plus negative 6 is negative 8. Keep the denominator the same. Now this is not in simplest form. I know that right off the bat because I have two even numbers. I know both of these can divide by 2 to get me negative 4/9. That is in simplest form. Also notice that the negative sign can go next to the 4. It can go in front of the bar. It can go in front of the 9. Anywhere you put that one negative sign still tells me that the entire fraction itself is negative. Next one. My multiples. Well, I think I know this one. 10. Keep it nice and simple. Don't go up to 20. You're going to have more to simplify later. Nice and simple here. Nothing's changing. We've got a negative 5/10. Don't forget to bring down the addition. All right, so 5 times 2 gets me to 10. 4 times 2 gets me 8. Adding a negative is the same thing as subtraction. So all I'm doing here is 8 take away 5 is 3. Keep my denominator the same. And that's that. Notice that my answers are in a box. You can put yours in a circle. But again, keeping everything really nice, neat, and laid out so that it's easy for anyone, especially me, to follow would be much appreciated. Last but not least, over here, I would like you to, let's go ahead and change this to a negative 3/6. I would like you to do this final one on your own and bring it with you tomorrow. And if you have any questions, try using my previous examples. Use the algorithm listed up here on your notes. Good luck. Thanks for watching, and I will see you tomorrow. Bye.